Greetings and welcome to lesson 10.3, page 414 and 415 and 416 on probability and statistics. Today, ladies and gentlemen, we are going to compute the experimental probability and the theoretical probability of an event. Now, we've discussed probability, and as such, you have actually seen and know how to do one of these because we have discussed probability. And of course, if you have actually read those pages, you would probably have figured out which one we've already done. So hopefully you've read them because that's what you are asked to do. I mean, it's very simple. Choose to do what you're asked to do, and you're most likely to find yourself to be more successful. Anyway, we'll save that for another day. Essential question: how can you use relative frequencies to find probabilities? So once again, if you did read it, you would notice that in the book, they talk about experimental probability first and theoretical second. And I chose to switch the order. The reason is, if you haven't figured it out yet, it is because we've already done theoretical probability. Theoretical probability, which is, and the book does not really spell this out very well. Theoretical probability is probability that's based on known facts and characteristics. In other words, if I have a coin, like they toss a coin at the Super Bowl to see who gets to choose whether they want the ball or not, if I have a coin, it has known facts or characteristics. So the probability of getting a result is known because probability is favorable over possible. And if you look at a coin, there are only two possible results, heads or tails. And so if you say you want tails, you're going to say 1 out of 2, 50-50 chance, known characteristics. All right? So let's do that a little bit. We're just going to make it quick, with a quick example, because we've kind of done this before. So the letters in the word Rossum are placed in a bag. You randomly choose one letter from the bag. Yes, I love that word, Rossum. Anyway, number one, what is the probability that we're going to select the letter S? So I look up there and I see there are two letter S's, so favorable. There are two favorable outcomes for the letter S out of possible 1, 2, 3, 4, 5, 6, 7 possible letters. So the probability is 2 out of 7. I could convert that to a decimal, and I could convert that to a percentage. Remember, in the real world, most probability is discussed as a percentage. All right? Probability, number 2, the probability of getting a vowel. So I have to look up here and see, ooh, I have an O, another O, and an E. And yes, those are two separate O's, so they count separately. So our favorable is 3. Again, the total possible is 7. And then probability of the letter A. Probability of the letter A, there is no A up there. So that's 0 out of 7. It is actually impossible for me to select an A from the bag, or you to select an A. And because it's a known fact that there's no A's in there. Now let's use what we know about theoretical probability and put it into the real world situation. It says, hey, the theoretical probability of winning a bobblehead when spinning a prize wheel is 1 out of 9. That's basically 11%. There are 3 bobblehead sections on the wheel. How many total sections are on the wheel? So, knowing that probability of an event is equal to favorable over possible, we can plug in what we know. It says, hey, the probability is 1/9. So right here, 1 out of 9 is equal to, there are 3 bobblehead sections on the wheel. Is that our favorable or the total possible number of sections? That's right, it's the favorable. So I would put here, out of the possible number, we don't know. Well, heck darns, that equation certainly looks like something I know how to solve real quickly. That looks like a proportion to me. So I can just go like this and say 27 equals X. So that means there are 27 sections on the wheel. Pretty easy. Moving right along. The probability of randomly selecting a winning ticket from a can is 0.005 or 0.005%. There are 2,000 tickets in the can. How many winning tickets are there? All right. So once again, we know that probability of any event is favorable over possible. Can't write that any faster. And all we have to do is plug in our numbers into this equation. We know that the probability is 0.005 or 0.005%. We knew there are 2,000 tickets in the can. That's the total number of tickets. How many of them are winning tickets? What's our favorable number of tickets? And in this particular case, all we have to do is get rid of that 2,000 by multiplying both sides by 2,000. And if you multiply both sides by 2,000, you get the answer of 10. So that means there's 10 tickets, 10 winning tickets. Boy, I can spell. That doesn't even look like the word winning. There we go. 10 winning tickets. Oh, I just love this. 10 winning tickets. And so, ladies and gentlemen, we have our last one. It says you are playing a game with a friend. You need to roll a total of greater than or equal to 10. The theoretical probability of rolling a number greater than 10 is 1 out of 6. If there are 6 possible ways of rolling a number or a total greater than 10, greater than or equal to 10, how many possible outcomes are there when you're rolling 2 number cubes? So you've played many games that require you to roll 2 number cubes, 2 dice. And then you get the result. So we have that, and we want a total of greater than or equal to 10. And we know that the probability of rolling a number greater than or equal to 10 is 1 out of 6. So I can write 1 out of 6 is equal to, well, it says there's 6 possible ways of rolling a number greater than or equal to 10. If you don't believe me, grab 2 number cubes and look and see how many there are. Well, there are 6, and we want to know how many possible outcomes there are when rolling 2 number cubes. Once again, looks like a proportion, so it can be solved like a proportion. 36 equals x, so there's 36 possible outcomes. The easiest way to tell is use 2 different colored number cubes so that you know which one you count first. Like if you use a red and a white, then you always go with the red number first. And then you get your total, and you'll see. Because is it the same if you have a red 1 and a white 2 as it is to have a red 2 and a white 1? Is that the same? No, but they still total 3, don't they? All right, we're done, so let's go to our quick write. Find the total probability of selecting a face card from a standard deck of 52 cards. Okay, so face cards, let me just remind you, face cards would be the jacks, the queens, the tens, jacks, queens, kings, and aces. We call those face cards. Jacks, queens, aces. Kings and aces. Jacks, queens, kings, and aces. All right, let's see if you can figure that out. And B, what is the probability of spinning a green on the spinner? Ooh, that looks kind of rough to figure out, but I bet you can do it. What is the probability of spinning green? Ladies and gentlemen, when you're done, take a quick break and come back and see us for the next video.